Okay, so this question comes from page 519, and it's number 7a. Now, most of the questions I've been getting have to do with rationalizing the denominator, not solving this question, but just to do quickly how I solved this question is they did tell me that the tan of some unknown angle is equal to root 2 over 4. And since I know that tan is equivalent to y over x, really what they gave me was, in standard position, the y value of root 2 and the x value of 4. So what I was able to do was to use Pythagoras' theorem, really, x squared plus y squared equals r squared, in order to solve the triangle. And when I solve the triangle, I can come up with all the other ratios. So 4 squared plus root 2 squared equals r squared. So 16, root 2 squared is just 2, equals r squared. So r is equal to the square root of 18. Now, for those of you who haven't rationalized denominators before, or even looked at radicals like this and simplified them, remember that another way of writing 18 would be 9 times 2. The reason I broke it down like that is because one of those factors, the 9, I can take the square root of, so I can simplify this radical by calling it 3 root 2. So now what you're going to do is you're going to take those values, and I just cleared my screen there, so that I have a root 2 here, a 4 here, and a 3 root 2 there. They asked me to determine the cotan of the angle, the cosecant of the angle, and the secant of the angle. So cotan, remember that's the reciprocal of tan. You actually had this when you started. We knew that tan was root 2 over 4, so cotan is the opposite, or the reciprocal, y over x, which is 4 over root 2. Now here's where I'm getting the questions. You can't leave a radical sign in your denominator. You need to get rid of that. The best way to get rid of it is to multiply both the numerator and the denominator by a common multiple. In this case, it makes sense to just use root 2 as the common multiple, because that would eliminate it entirely in the denominator. In the numerator, it just gives me 4 root 2, and then in the denominator, root 2 times root 2, that's just like the problem we had on the last page, root 2 squared. A squared symbol and a square root symbol cancel each other out. I'm just left with a 2. Now, if you've gotten this far, you've done really well, but you should notice that your whole numbers can be reduced. 4 over 2 is the same as 2 whole, so 4 divided by 2. So really I could simplify that by dividing the 4 by 2 and the denominator by 2, which would leave 1 down here and a 2 up there. So it's really 2 root 2 over 1. There's no need to write it over 1 though. You can just call it 2 root 2. As for cosecant, that's r over y. So we're just going to take our r value and put it over top of our y value. This is really good practice. Again, we need to get rid of that radical sign in the denominator, and the best way is to just multiply the numerator and the denominator by whatever is in the radical. So root 2 times root 2, we saw that just makes 2. Now what happens in the numerator? The 3 is okay, but then I've got the root 2 times root 2 again, and you can try that in your calculator and you'll see that it does equal 2. So I'm just going to put it in brackets here. I haven't fully simplified yet, but 3 root 2 times root 2 is the same as saying 3 times 2. So you might have multiplied those two numbers together in order to get 6, or you might have stopped like I did and then reduced by 2 here. Okay, so if you had entered in your calculator 3 root 2 times root 2, you would have gotten 6 divided by 2, and so you still would have ended up with the final answer of 3. And finally, the secant, which is r over x. So 3 root 2 over 4, and you're probably happy with that one because there's no need to reduce it.
Made with Doodlecast Pro.